Hello everyone, today we're going to take a look at page 46, factoring trigonometry problems to solve them. So we're going to be applying some factoring rules today, which looks a little bit weird because we are looking at it with the context of trigonometry. So you are going to have to look around the fact that there are trig functions here. So if you take a look at this first one, you can see that it says 4 sine squared theta minus 1, right? But if you were instead to replace this sine squared of theta with x squared, it would say 4x squared minus 1. You know how to factor that. That is something we learned how to factor like at the beginning of Algebra 1. You're just taking those same rules and applying them here. So we would know, for example, this would factor into 2x plus 1 and 2x minus 1 because the square root of 4x is 2x. The square root of negative 1 is 1, and then you give 1 a plus and 1 a minus. Apply that same rule over here. 2 sine of theta plus 1, 2 sine of theta minus 1. Exact same rules. Just treat those trig functions as x's, and you'll kind of see how these come together. Example here. Same thing as this last one. You've got a perfect square here and a perfect square here with an operation of subtraction in the middle. So it's another difference of two squares happening here. So we take the square root of sine, which is sine of theta, plus the square root of cosine squared, which is cosine of theta, and then do the same thing, but this time put a minus in the middle. So anytime we see a situation that we have two perfect squares, two things we can square with a minus, that's what we're going to do. In this one, same idea that there's a minus here, but we recognize that it's not a perfect square. Like this piece and this piece are perfect squares, but this little cosine theta right here, that's not a perfect square. So this is not going to work that way. What we do have here, though, is that this has a cosine and this has a cosine. So we could factor a cosine out of this. So factor cosine theta out, meaning in the beginning, this cosine goes away completely. So we just have sine squared of theta left over, keep our operation. Here when we take one cosine away, we have cosine of theta left, and it's going to factor out like that. So we have one cosine left and a sine squared. So it's still not a difference, two squares, nothing I can do there. We're going to have to stop right there. All right, coming down here, you can see these ones look more like our regular factoring where we say what multiplies to make the middle and adds up to make the end. So in this case, our end term is that negative 15. So I need two numbers that would multiply to make negative 15 but add up to make negative 2. Well, I know that 5 and 3 are going to be the choices, and since I want it to be a negative 2, the negative has to go on the 5. So factoring is going to look the same way. It's just that because there's a sine squared in the beginning, that sine squared becomes sine of theta, sine of theta. So I've got sine of theta in this parentheses, sine of theta in this parentheses, and then that minus 5 and that positive 3 that we found, those go right here. So sine of theta minus 5, sine of theta plus 3. And if you were to refoil that and distribute it all back together, when you multiply that sine by plus 3 and this sine by negative 5, 3 sine and negative 5 sine would give us that negative 2 sine theta right there that we're missing. So it would ultimately go back to exactly what we had before. Same thing here, except there's a 4 in the beginning. Anytime this happens where there is a number in front, we know that we can't just multiply to get this last term and add up to make the middle. It won't work correctly. What we have to do is we have to multiply this term to the end and then do a splitting the middle term problem. We have to split that middle term to figure out what's going on. So in this case, 4 multiplied by negative 3 gives us negative 12. So I need two numbers that multiply and make negative 12 and add up to make this positive 1 in the middle. So I know it's going to be 4 and 3, and the negative is going to have to go on the 3 because 4 minus 3 would give us positive 1. So that's exactly what I'm going to split the middle term into 4 tangent of theta and negative 3 tangent of theta. And since I've got a 4 tangent squared here, I'm going to want the 4 to go first so that when I factor by grouping at the end, I can factor out that 4. So let's do that. 4 tangent squared. And then I'm going to have the plus 4 tangent of theta minus 3 tangent of theta, and then that minus 3 at the end. And now I can do my factor by grouping. Group those two together and those two together. So in the first one, I could factor out a 4 tangent of theta, and I have tangent of theta left over here. And the first, this piece right here, I've got plus 1 left over. And in the other one, I could factor out a minus 3. So when I take a minus 3 out of the first term, I have tangent of theta left over, and I have a plus 1 left over. And since they come out to the exact same thing, that means we did it right. Remember, what we're looking for is that this and this are exactly the same. And if they are, we're going to factor that out. So we're going to write tangent of theta plus 1 one time, And the remaining factor, the remaining parentheses will be this one and this one together as a parentheses. So 4 tangent of theta minus 3. And those are our two factors. All right, and the last one up here, cosine to the fourth plus 2 cosine squared plus 1. Well, this one's got this cosine to the fourth, which might seem scary at first, but all that means is when we go to do our factoring step here, we're going to separate it into cosine squared of theta, cosine squared of theta. And then we look at our term. There's nothing in the beginning to multiply, so we just have a 1. So I need two numbers that multiply to make 1 and add up to make 2. Obviously, that's going to be 1 and 1, so plus 1 plus 1. And now, since those two things are the exact same, I could rewrite them as one thing. So cosine squared theta plus 1, and I'll put a squared up here to represent that there's two of the same thing. And that would be our final factor. So let's actually take this now and apply this to some problems, right? So that's how you do those factoring problems. Now we're going to take and actually apply it to solving factoring equations, trigonometric equations that have factoring problems in the beginning to be able to solve them. So the first rule here is that you always have to get it equal to 0, like we've done here. This is already equal to 0, so we know we could solve this one right away. So we're going to start by looking at this side and saying, hey, can I factor 4 cosine squared minus 1? And we recognize that there is a difference of 2 squares, just like literally exactly the same as this first one, except here I use sine squared. So here I've got cosine squared, so it's going to separate into 2 cosine of theta, 2 cosine of theta. We'll put a plus and a minus, and since 1, the square root of 1 is 1, we'll put a 1 and a 1, and that equals 0. So what happens now is because we have this equation multiplied by this equation, if we're going to get it to equal 0, one of these has to be 0. Either this has to be 0 so that 0 times whatever this is would give us 0, or this has to be 0 so 0 times whatever this is here, if I multiplied that, I'd get 0. Either way, I just need to prove that either this is 0 or this is 0. So we're going to set up two separate equations. 2 cosine of theta plus 1 equals 0, and 2 cosine of theta minus 1 equals 0. And we're going to solve each of those. So here I'm going to subtract 1, and then I'll divide by 2. I'm going to kind of do that as 2 steps. So you can see that if I subtract the 1, I get cosine of theta equals negative 1. And then when I divide by 2, I get negative 1/2. Likewise, over here, I'm going to add the 1, so I'm going to have positive 1, and then I'm going to divide by 2. So I end up with cosine of theta equals positive 1 divided by 2. So now I've got these two equations, and I want to solve them on the interval right here, 0 to 2 pi. So that means that I'm looking at the entirety of the unit circle. I'm not going to infinity. I'm just looking at the unit circle one time and saying, on the unit circle, where would cosine equal negative 1/2? That's the first one. So where does cosine equal negative 1/2? Well, we know that negative 1/2 comes up in 2 spots. Because cosine is the x-coordinate, we know that anywhere in the the second or third quadrant is going to represent our negative cosines. So I know that it's going to be at pi over 3 is kind of like where that 1/2 comes up. But in the second quadrant, pi over 3 would be 2 pi over 3. The numerator is 1 less. And in the third quadrant, the numerator is 1 more, so 4 pi over 3. So those would be our 2 spots that we would definitely get negative 1/2. And for the other one, where cosine of theta equals positive 1/2, that would be, since again it's the x-coordinate, that's in quadrant 1 and quadrant 4. So in quadrant 1, cosine is 1/2 at positive pi over 3. And in quadrant 4, it's at 5 pi over 3. So we would have all 4 of those answers as valid answers to this equation. All right, in this next one, you can see that this one, you've got 3 tangent squared minus square root of 3 tangent u. So this is going to be one of those situations where we want to do a factoring question first. We need to factor out the tangent first. Again, what's important is that this side is already equal to 0. Notice there's a little difference here, though. This one's not doing 0 to 2 pi. This is doing pi to 3 pi over 2. So what this tells us is that we're only looking at quadrant 3 on the unit circle, which is going to make things a little bit easier. We have less answers because we only have that 1/4 section of the unit circle we have to look at. All right, so again, there is a tangent here and there's a tangent here, so let's factor that tangent out. So tangent of u comes out. The beginning is 3 tangent u. And then when I take the tangent u out here, I just have minus the square root of 3. And it still equals 0. So again, that means that either this or this has to equal 0. Each of them can equal 0. So either tangent of u equals 0 or 3 tangent of u minus the square root of 3 equals 0. The nice thing is the first one's already done, right? This one's already solved. Tangent u equals 0. So we just got to solve what u could be then. On this one, though, we're going to add the square root of 3 to this side. So now I have positive square root of 3. And then I'm going to divide by 3. So ultimately, tangent of u equals the square root of 3 divided by 3. Let me bring that over here. All right, so on our unit circle, we know that tangent is always equal to 0 at the x-axis. Because tangent is y over x, we know that along this x-axis at the point 1, 0, or there's the other part right here, or at negative 1, 0, if I take y over x, I get 0 over 1 or 0 over negative 1. So those are the only spots that we're allowed to use 0 at. It doesn't happen at these spots because this would give us 1 over 0 or negative 1 over 0, which would be undefined. So these ones cannot be answers. It has to be either at 0 or at pi. But since our answer has to be between pi and 3 pi over 2, the only answer that's going to work here is when we're equal to pi. And for the square root of 3 over 3, we got to think about doing our y over x. And we know that at pi over 6, we would get 1 over the square root of 3, which if I rationalize 1 over the square root of 3, I would get square root of 3 over 3. So this is going to happen at pi over 6, but not pi over 6 in quadrant 1. We need pi over 6 in quadrant 3, which is always 1 bigger. So it's going to be 7 pi over 6 in quadrant 3. That would be where we'd get positive square root of 3 over 3 because it really would be negative 1/2 divided by negative square root of 3 over 2. So the negatives would cancel and give us a positive. All right, and example 4. This one we can see is going to be like a standard factoring question, except we got this 2 in front right here. This 2 right here tells me we're going to have to split the middle term. So we're going to multiply this 2 over here to this negative 2. And we are going to end up with sine squared of alpha plus 3. Oops, sorry, I'm doing that the wrong way. Hold on. Ignore me. Okay, 2 times negative 2 is negative 4. Sorry, I forgot to do this step. So what two things would multiply to make negative 4 but would add up to make this positive 3 in the middle? So I know that's going to end up being positive 4 and negative 1, right? Positive 4 and negative 1 multiply to negative 4 but would add up to make that positive 3. So that's how I need to split my middle term here. So I've got 2 sine squared of alpha plus 4 sine of alpha, then the minus 1 sine of alpha minus 2, still equal to 0. All right, do our grouping here, group, 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 group. I'm going to need to factor in the first one, a 2 sine of alpha out. So I'm left with sine alpha plus 2. And in the second one, I'm going to need to factor out a negative 1, which becomes sine of alpha plus 2. And again, like we talked about earlier, because these two things here match, because this and this match, we get to rewrite it as a single term. And the other two pieces, here and here, make up our missing term here. So 2 sine alpha minus 1 equals 0. And we're just going to set each of those equal to 0. So this equals 0. That was a terrible bracket. And that equals 0. So coming over here, then let's do that. Sine alpha plus 2. So sine of alpha plus 2, we're going to subtract 2 from both sides. That would cancel. And we get sine of alpha equals negative 2. Which, if you think about that, is negative 2 even on the unit circle? No. The unit circle only goes from negative 1 to 1. So because we got negative 2, we know this does not exist as a possible answer. And for the other one, 2 sine of alpha minus 1. 2 sine of alpha minus 1 equals 0. So we'd add 1 to this side and then divide by 2. So sine of alpha would give us 1/2. So where would sine of alpha give us 1/2 on the unit circle? And again, we're looking at the entirety of the unit circle here because it's 0 to 2 pi. So on the unit circle, sine of 1/2 would come up anytime the y value is equal to 1/2. So we know that's going to happen in 1 and 2. So alpha would happen at pi over 6 is where we'd have y equals 1/2. And alpha would be positive 1/2 at 5 pi over 6. So those are the only two answers that would actually work for this problem. The first one doesn't give us any because it did not exist. So those are the only two answers we could use. All right, and that brings us into this last question, which I can tell you that there is a small typo in this last section. This should not be to the fourth. This should be to the third. secant cubed of x minus 4. So what I can say here is that we see that we've got things on both sides. Remember how I said that it had to be equal to 0 earlier. This side does not equal 0, and we need to make that happen. So we need to move all that stuff over this direction. So let's start with this. We're going to subtract secant squared to this side. Subtract secant squared, which there really is nothing to subtract it to. So it's going to be its own term. But then here I've got this 1 that I can add, and I could add that 1 onto the 4. So what's going to happen is the secant cubed of x goes first, then that minus secant squared of x, then we have our minus 4 secant of x, and the only terms that I can actually put together is that plus 3 and that plus 1 to make plus 4, and now on this side we have 0 left over. Noting we are looking at the whole unit circle, that will be important in a few minutes. Now we're going to go ahead and solve this, and you can see this is going to be a factor by grouping question, right? If we group those two terms together, in the first one I can factor out secant squared of x, I'm left with secant x minus 1. Second one I can factor out a negative 4, and when I do I have secant x minus 1. And that puts us in good shape because our two terms match. We get to write them as one term, and the other one becomes secant squared x minus 4. Before I keep going though, I definitely see that I could factor even further. This right here is a difference of 2 squares, so I'm going to be able to take that even further. So I know that this will be secant x minus 1, and that's going to factor into secant plus 2 and secant minus 2. So we're in good shape now to solve this. Bringing these over here, we got 3 equations to work with. So the first one is secant x minus 1. So secant x minus 1 equals 0. So I'm going to add 1, secant of x equals 1. Now we don't really have the circle memorized, the unit circle memorized for secant, so I need to switch that to its reciprocal, into its sine or its cosine version, because that's what we know how to work with. So if I change secant to its reciprocal cosine, it means I have to take the reciprocal of 1, but that's easy. The reciprocal 1 is 1, because it's 1 over 1. So we need to really find the cosine when the cosine equals 1. And that only happens in one spot. The cosine would equal 1 when the x value equals 1, which is going to happen at pi over 2, going straight up on the unit circle. All right, the second one is secant of x plus 2. So secant, I put the 2 early, I'm sorry. Secant of x, was it plus 2? Yeah, plus 2 equals 0. So solving this, we'd subtract the 2 to the other side. And then again, we do the reciprocal. The reciprocal of secant is cosine, and the reciprocal of negative 2. Since this is negative 2 over 1, when I do that reciprocal and flip it, the 1 moves up top and the negative 2 moves to the bottom, or the negative can be in front. It doesn't matter. But it becomes negative 1/2. So when does the cosine give us negative 1/2? Well, we know that comes up at 2 spots because the cosine is the x. It comes up at the second and the third quadrant. So we know that cosine would equal 1/2 at pi over 3. So for it to be negative, it's going to be 2 pi over 3 and 4 pi over 3. And then we got one more, and you can see that's kind of just going to be the opposite, right? The other one is secant of x minus 2 equals 0. So secant of x minus 2 equals 0. So we know that's going to become secant of x equals 2. And when I do my reciprocals, cosine of x equals, and we know the reciprocal of 2 is 1/2, and it's positive this time. So my positive versions of these answers would come from the first quadrant, so pi over 3, and from the fourth quadrant, so 5 pi over 3. So we end up getting all the pi over 3s on the unit circle because we're doing positive a and negative 1/2. And those would be our 5 complete solutions that would work for this problem. All right, if you have any more questions, please come talk to me. Hopefully this helps out some. Hope you